Hey there, so today I'm doing my math project on finding reciprocal trig ratios. I already set up a triangle here, a right triangle actually. Let me draw in that 90-degree angle right here. This is a right triangle, so because it is a right triangle, we are going to be using SOHCAHTOA in order to determine the six ratios for angle D. So we're going to be determining six ratios for this angle D right here. Sorry about that. Right here. Okay, let's get started. So, SOHCAHTOA. So, the number in front is the S right here is going to stand for sine. So, we're just gonna write out sine. Okay. Sine of D. The reason we write this SOHCAHTOA is because you look at the S, the capital S right here, it tells you whether it's sine, cosine, or tangent. And these two letters that come after are going to give us almost the formula for how we're going to find the sine of D. So OH, so that O right there is going to stand for opposite. We're just going to abbreviate it. Opposite. And that H is the second letter is always going to go underneath, and that H is going to stand for hypotenuse. That's a big word, so we're going to abbreviate it once more. And sorry about this stylus. I've been having a lot of issues finding a way to write, and this is the only application. Okay. So opposite over hypotenuse. Okay. So in this case, D right here. So what is opposite from D? The side opposite from D is 16. So we're gonna go all the way across. See the 16 across the way? That's gonna be our opposite. So we're gonna put 16 on top. Underneath the 16, we're gonna put our hypotenuse. Our hypotenuse is always across from the 90-degree angle, and it's our biggest side. So our hypotenuse is 4. So we're gonna put 4 underneath. Alright, so now we have our sine. We can simplify that. 16 goes into 4 times. So our sine of D is 4. Now moving on to the C right here. Once again, this capital C is going to indicate to us that we are using cosine. Cosine of D. Of D. The cosine of D is going to be, so once again, we look at what comes after the C, the H, the A, and the H right here. That's going to indicate what our formula is going to be. So A, the letter that comes first, stands for adjacent. We're going to abbreviate that. And the term coming after it, H, is going to stand for hypotenuse. So adjacent over hypotenuse is going to be our formula for cosine of D. So we know that D right here is the angle we're basically starting from vertex. And from there, our adjacent is basically going to be the side closest or basically on the angle that is not the hypotenuse, which would be 8 in this case, would be the adjacent. So we're going to put an 8 right there, and then underneath it, we already know the hypotenuse along the side across from the 90-degree angle, that's 4. Also, I apologize for the terms, I was just using an example. Obviously, in a real equation, the hypotenuse would be greater than the two legs, but we're just making it work. I just want to show you guys how these trig functions work. So we could then simplify this to 2. 8 goes into 4 2 times. Our cosine of d would be 2 in this case. Now we are going to do the tangent. That t right there, tangent. SOHCAHTOA is great because it allows you to just remember the steps as long as you can write it out. Sorry about that. Okay. So now we're going to do the tangent of d. So we're going to once again look at those two numbers that come after the t, which is O and A. So O is going to stand for opposite. And then right under that, the A is going to stand for adjacent. We're going to abbreviate it. Okay, so we already know our opposite and adjacent from D, starting at D. Remember that tangent of D, you start at D. If it was tangent of F, you would start at F and look from there. So from D, the opposite is going to be 16, as we learned earlier. And the adjacent is going to be 8. This will then simplify since both go into 4. Into 4 over 2. I mean 2 over 1. Sorry about that. Which would just end up being 2. 8 times 2. Okay. Now that we got all of those out the way, now we're going to go into secants. So basically, one thing to keep in mind when doing secants is that secants are basically just, if you take them in order, the order I'm going to show you, they're basically just the opposite of the SOHCAHTOA. Basically just total opposite. So we're going to start off with cosecant. So we're going to abbreviate that with CSC. I'm going to be scrolling up and down. Sorry, I ran out of room for the triangle, but I'll show you guys how to find these. Cosecant of D. Cosecant of D is going to be the complete opposite of sine of D. So sine is opposite over hypotenuse. So instead of doing opposite over hypotenuse, we're going to do hypotenuse over opposite for cosecant. Just take the total, take your formula or your pattern for sine, flip it. Usually going to give you a smaller number depending on the problem. Okay, now that we have hops, we could go up and look at the triangle, but we know that our hypotenuse is 4. Knowing that our hypotenuse is 4, we can see right here and up here, our hypotenuse is 4. The line across from the 90-degree angle, and our opposite is 16, as you can see right here. So we're just flipping it. It's gonna leave us with cosecant of 1/4. Perfect. Now we're going to move on to just secant. So we're going to abbreviate that with SEC. Secant of D. So we're doing all 6 trig functions. All 6 of them. Okay. So our secant is going to be the complete polar opposite of our cosine of D. So we're going to take adjacent over hypotenuse, that formula we found, and just flip it. And that's going to be hypotenuse over adjacent. Sorry, it's getting a little messy. The stylus is not cooperating. So hypotenuse over adjacent. We know our hypotenuse is 4. And we know that our adjacent angle is 8. The adjacent angle of D, that's going to leave us with 1/2. Alright, I ran out of room, so I think I'm just gonna squeeze in cotangent up here, if that's alright. Sorry, it's getting messy. Cotangent, we're gonna abbreviate that to COT. Perfect. Cotangent is going to be the complete polar opposite of tangent, which is opposite over adjacent. This is going to leave us with adjacent over opposite. So cotangent of D is then going to be so tangent opposite over adjacent, so adjacent over opposite. Over opposite. Okay. Adjacent over opposite is going to leave us with, so the term opposite to D would be 6, or I mean, yeah, sorry. The term adjacent would be, sorry about that. So we got 16 over 8 for the tangent, opposite over adjacent. So now it's going to be 8 over 16. 8 over 16. Which is once again going to leave us with 1/2. Basically the total opposite of what our tangent was. So you can kind of see the pattern. So for example, for sine we got 4. For secant, the opposite of sine, for sine we got 4, and then for cosecant we got 1/4. So we kind of got the opposite. For cosine we got 2. For secant we got 1/2. For tangent we got 2. For cotangent we got 1/2. So we're always kind of doing the opposite when you're going from secants to SOHCAHTOA to those secants or cotangent. You're just flipping it around. As long as you understand SOHCAHTOA, you'll be fine. I hope this lesson helped you guys out.